An expedition into the realm of ancient scientific mastery begins with an exploration of Babylonian astrology, a discipline where mathematics and celestial observation harmonize to forge unprecedented predictive capabilities. In times long past, the Babylonians established a rigorous framework that married empirical data with sophisticated numerical computation, laying an essential foundation for modern astronomy and advanced predictive astrology. Their profound commitment to accurate measurement and systematic record-keeping allowed them to perceive patterns in the movements of celestial bodies, patterns that were both consistent and quantifiable. By carefully recording the complex interactions between the moon, sun, and the 5 visible planets, Babylonian scholars generated a comprehensive repository of astronomical data. This repository not only served religious and political functions, but also advanced mathematical techniques in ways that are still recognized today. The methodological rigor demonstrated by these early pioneers resonates with contemporary scientific practices, where validation through empirical observation remains paramount. Through step-by-step calculations and refined arithmetic procedures, Babylonian astrologers constructed models. They predicted phenomena such as eclipses and planetary conjunctions with remarkable precision. The ancient texts and astronomical tables they compiled provide evidence of a deeply analytical approach to the cosmos, one that combined theoretical insight with practical application. In this journey, we shall delve into the technical depths of Babylonian mathematical models, their systematic methodologies, and the quantitative frameworks employed to forecast celestial events. Our discussion will critically assess these innovations, considering their historical context and technical sophistication, while drawing parallels with modern predictive techniques in the field. This narrative not only honors the remarkable ingenuity of these early scholars, but also reinforces the notion that the synthesis of mathematics and empirical observation is a timeless endeavor. Throughout this exploration, we remain committed to meticulous analysis and precision, ensuring that every numerical nuance and methodological detail is examined with expert care. Emerging from the confluence of ancient religious rituals and early scientific inquiry, Babylonian astrology was born in a milieu where knowledge and power were inseparable. The vast empire of Babylon thrived on a cultural reverence for celestial phenomena, a reverence that soon became institutionalized through the meticulous work of scholars and scribes. These early academics, often serving in royal courts, undertook the formidable task of recording the motions of the heavens. They adopted a quantitative approach, blending precise arithmetic operations with systematic observation, a combination that was revolutionary for its time. Political imperatives, religious mandates, and the inherent human curiosity about the cosmos drove the Babylonians to innovate at the intersection of astronomy and mathematics. In the academic precincts of ancient Babylon, the creation of astronomical records was not merely clerical work. It was seen as a profound service to the state and the divine order. The state-sponsored research was directly linked to the administration of the empire, with predictions of celestial events influencing the outcomes of military confrontations. Within the temple complexes and palace libraries, scholars developed extensive compilations of astronomical data, which were later structured into complex tables and cycles. They noted that certain celestial events, such as eclipses and planetary alignments, exhibited regular periodicities. Through comprehensive analysis, these experts identified patterns that allowed them to predict future events. Notably, the identification of the Saros cycle provided an early mathematical framework that forecasted eclipses with a periodicity of approximately 18 years. This finding not only demonstrated a profound understanding of astronomical mechanics, but also established a standardized model that would influence subsequent scientific methodologies. Embedded in this historical narrative is the delicate balance between empirical evidence and divine interpretation. The Babylonian approach necessitated that celestial events be interpreted as omens, thus interweaving scientific observation with ritualistic significance. In this rich historical context, the birth of Babylonian astrology was as much an exercise in scientific innovation as it was a reflection of the society's deep-seated need to harmonize earthly governance with cosmic order. Consequently, the synthesis achieved by Babylonian scholars exemplifies a pioneering spirit where discipline and observation coalesced, fostering an environment of rigorous intellectual inquiry. Their methodical approach, underpinned by concrete mathematical principles and a steadfast commitment to accuracy, set a benchmark in early scientific practice that resonates unequivocally with modern methodologies. This legacy of empirical rigor remains indispensable to the scientific enterprise. Babylonian astrologers revolutionized the understanding of celestial mechanics through their innovative application of mathematics. Central to their methods was the development of precise arithmetic techniques and rudimentary geometric models that enabled them to quantify the apparent motion of planets and stars with unmatched fidelity. They employed base 60 numeral systems, which facilitated the accurate calculation of time intervals and angular measurements. This cuneiform numeral system, with its exceptional divisibility properties, provided advantages in computing periodic phenomena that modern scholars continue to appreciate. The Babylonians were adept at assimilating observational data and converting it into numerical constants that could predict the positions and velocities of celestial objects. Their method was characterized by a step-by-step computational approach, often documented meticulously on clay tablets. Each tablet, a record of empirical observations, served as both a ledger and a mathematical blueprint for future predictions. The analytical techniques included the use of difference methods to estimate the acceleration and deceleration of planetary bodies. Babylonians observed that the motion of a planet was not uniform, but varied in predictable cycles. By applying successive approximations, they could calculate the varying speeds along an elliptical path, projected on the celestial sphere. These approximations formed the basis for more complex mathematical formulations that would later influence Greek astronomers. Furthermore, the Babylonians introduced concepts that hinted at periodic functions, recognizing that celestial phenomena were cyclic in nature. Their study of eclipses revealed that the regularity of these events was intrinsically tied to the interplay between lunar and solar cycles. The ability to subdivide time into finer increments allowed them to establish periodic cycles, such as that of the moon's phases and the Saros cycle for eclipses. With remarkable foresight, they integrated these cycles into comprehensive predictive models that accounted for both astronomical and terrestrial events. This integration underscored the dual emphasis on mathematical precision and practical application. By distilling observation into quantifiable variables, Babylonian mathematicians transformed abstract celestial movements into defined numerical relationships. Their contributions, encapsulated by arrays of computed values and formulated hypotheses, were not merely theoretical exercises, but tools that held significant utilitarian value. They introduced a framework where calculation was a central pillar in decoding the workings of the cosmos, emphasizing that patterns in nature could be expressed through mathematics. As a result, Babylonian astrology became a synthesis of mathematical rigor and astronomical observation, a heritage that significantly informed subsequent scientific revolutions. The mathematical innovations pioneered by these ancient scholars continue to be studied for their methodological clarity and enduring influence on numerical astronomy. Their work established a paradigm in which the interplay of observation, computation, and cyclical analysis spurred advancements that remain integral to the scientific method today. In examining this pioneering approach, we not only appreciate the historical significance of Babylonian innovations, but also recognize their profound impact on the evolution of mathematical techniques in predictive science. In summary, the computational techniques and numerical insights developed by Babylonian scholars represent an extraordinary convergence of practicality and theoretical rigor, forming the bedrock of predictive models that have withstood millennia of scrutiny. A critical development in Babylonian astrology was the creation of extensive astronomical tables that synthesized observational data into predictive cycles. These tables, inscribed on durable clay tablets, meticulously cataloged the rising and setting times of the moon, as well as the synodic periods of visible planets. Scholars computed these cycles with astonishing regularity, identifying numerical patterns that revealed the systematic nature of celestial movement. Notably, the Saros cycle, a period of roughly 18 years, emerged as a fundamental element in forecasting both lunar and solar eclipses. This cycle served as a cornerstone for predictive methods, enabling astrologers to pinpoint the occurrences of eclipses with considerable precision. The formulation of these tables required an integration of observational acumen and mathematical precision. Babylonian scribes developed algorithms constrained by the limitations of their numeral system, yet imbued with an impressive accuracy. That allowed for the projection of future events. Meticulous records of celestial events provided a robust data set from which these cycles could be delineated. Each entry in the lunar and planetary tables was derived from repeated observations over extended periods, lending empirical weight to the numerical predictions. Moreover, the periodicity evident in the tables underscored the deep connection between mathematical consistency and natural phenomena. The recognition that eclipses repeated with regular periodicity enabled the formulation of predictive models that were both deterministic and reproducible. Babylonian scholars systematically refined these cycles by continuously updating their tables with new observations, thereby enhancing the reliability of their forecasts. The scientific method, in its early form, was exemplified in this iterative process of observation, record-keeping, and calculation. In addition, the detailed documentation of planetary movements in these tables provided critical reference points for further theoretical developments. Each cycle, carefully measured and recorded, contributed to a cumulative understanding of the dynamic interactions governing celestial mechanics. The tables were not simply records, but functioned as active tools in the continuous endeavor to decode the movements of the heavens. In this way, the Babylonian compendium of astronomical tables remains an enduring testament to the ingenuity of ancient scientific processes, integrating mathematical formulations with empirical observations to create predictive cycles that revolutionized early astronomy. These innovative tables not only served as astronomical guides, but also initiated a new era of data-driven prediction in ancient science. The sophistication ingrained within each cycle and calculation laid the groundwork for later advancements in calendrical systems and astronomical theory. By persistently correlating observed data with calculated predictions, Babylonian astrologers advanced an empirical tradition that fused mathematical rigor with practical necessity. This systematic approach catalyzed an enduring legacy, elevating the predictive capacity of ancient sciences, and establishing benchmarks that continue to inform contemporary methods in the study of celestial dynamics. Indeed, empirical verification constituted a cornerstone of Babylonian astrology, a process in which observational records were continuously compared against predictive models. The astrologers employed a feedback loop, wherein each predicted event was meticulously documented and subsequently evaluated in light of new astronomical occurrences. Through this rigorous method, the reliability of the predictive models was constantly tested and refined. The process involved revisiting ancient records, scrutinizing discrepancies between predicted and actual events, and adjusting computational procedures accordingly. Such detailed empirical practice underscored a commitment to accuracy that resembled modern scientific experimentation. This methodological rigor was evident in the way Babylonian records meticulously categorized omens and their corresponding celestial events. For example, when an eclipse was forecast, the ensuing event was carefully recorded along with its timing, magnitude, and any accompanying atmospheric anomalies. Babylonian scholars documented these occurrences over successive cycles, establishing a rich archive that not only verified previous predictions, but also provided a wealth of data for subsequent analyses. Each piece of empirical evidence contributed to a dynamic database that enabled incremental improvements in the underlying mathematical models. It was a form of early hypothesis testing, where the veracity of a model was measured against the persistent reality of the cosmos. Integral to this process was the continuous interplay between observational data and predictive computation. The astrologers demonstrated an unwavering commitment to recalibration, recognizing that even slight variations in celestial behavior necessitated immediate adjustments in their calculations. This iterative process, blending rigorous observation with advanced numerical methods, imbued Babylonian astrology with a sense of reliability and precision that was remarkable for its era. In essence, the integration of observation with calculation transformed abstract predictions into robust forecasts. This empirical legacy, rooted in centuries of careful documentation and methodical revision, exemplifies an early scientific approach. The Babylonian framework not only validated its own predictive claims, but also set a paradigm that would later influence experimental methodologies in diverse fields. By emphasizing continuous verification, the system stood as a testament to the sophisticated balance between theory and observation, a balance that remains at the heart of modern scientific inquiry. This enduring commitment to empirical validation not only enhanced the predictability of celestial events, but also solidified a methodological framework that continues to echo throughout modern scientific disciplines. In its precision, Babylonian astrology exemplified the fusion of tradition with innovation. The legacy of their empirical rigor endures robustly even today, indeed, unquestionably. Mathematical precision in Babylonian astrology extended its reach far beyond academic inquiry. It was instrumental in consolidating the social, religious, and political authority of the astrologers. Celestial predictions, rendered with rigorous numerical methods, provided not only forecasts of eclipses and planetary alignments, but also interpretations with significant implications for governance. Within the Babylonian state, accurate predictions of astronomical events served as validation of divine favor and were used to legitimize the ruling authority. The synchronization of celestial events with critical state functions reinforced the notion that the cosmos itself endorsed the decisions of kings and administrators. The role of numerically driven omens in statecraft is evidenced by the meticulous records maintained by astrologers, who were often summoned to provide counsel during periods of political uncertainty. Their ability to forecast celestial phenomena was interpreted as an indication of a higher cosmic order, thus justifying military endeavors, agricultural planning, and religious festivals. The high degree of accuracy achieved through mathematical calculations propagated a view of order and predictability in the cosmos, aligning the ruler's policies with the supposed will of the divine. In this manner, Babylonian astrologers occupied a unique position. At the interface of science and theology, wielding both technical prowess and spiritual authority, the legacy of their work contributed significantly to the institutionalization of astrological practices across the ancient world, influencing subsequent traditions in Egypt, Greece, and beyond. Their prognostications were not merely abstract exercises in numerical computation. They possessed tangible political utility, endowing decisions with an aura of inevitability. That resonated with both the populace and the elite. Consequently, the interplay between mathematical innovation and authoritative interpretation fostered an environment in which scientific expertise bolstered the power of the state. Through the dissemination of precise, mathematically underpinned predictions, Babylonian astrologers became indispensable advisors, ensuring that the alignment of celestial and terrestrial happenings was harnessed to support and guide societal governance. Their meticulous integration of quantitative methods with socio-political imperatives not only solidified their authority in antiquity, but also established a precedent for the fusion of science with statecraft in successive civilizations beyond measure. In concluding this exploration, the enduring legacy of Babylonian mathematical and predictive innovations becomes manifest. The systematic approach to celestial prediction, with its intricate numerical methods, precise astronomical tables, and rigorous empirical verification, continues to resonate within modern scientific disciplines. This historical synthesis of mathematics, observation, and divination not only advanced early astronomy, but also laid the conceptual groundwork for later scientific revolutions. By intertwining empirical data with sophisticated computational techniques, Babylonian astrologers forged a methodological paradigm that underscored the universality and timelessness of mathematical inquiry. Their contributions remind us that precision in measurement and a relentless pursuit of observation are fundamental to our understanding of the cosmos. Today, as modern methodologies build upon these ancient foundations, the cosmological insights of Babylonian scholars remain a testament to the power of empirical science in deciphering the natural world. Thus, the legacy of Babylonian innovations endures as an enduring beacon for scientific progress, indeed.